Okay, so here we have a comparative. Okay, so here we have a comparative question from the quant section at the GRE. Alright, so it tells us that A is greater than 0, and we have to decide whether quantity A or quantity B is larger, which one of them is larger, or if they're equal, or if we don't have enough information to be able to determine which one of them is larger. Alright, so like any of these quant questions, you can always reduce the quantity given, and I think that's the best approach that we can take here. Once we reduce it, it will be easier to compare quantity A and quantity B. In quantity A, we have a to the fourth power Okay, so we have a to the fourth power. Wait, no, not good, not good. Okay, so in quantity A, we have a to the fourth power times a to the fifth power. Alright, so we're going to rewrite it here as a to the fourth power times a to the fifth power. Alright, multiplication rule. Whenever you have a base that is the same for both and you're multiplying, you're going to add the exponents together. So we're going to get a to the ninth power here on this side. Alright, so that's kind of simplified as a to the ninth power. And then we're going to have here on the other side a to the third power, everything raised to the second power. Alright, here the rule of multiplication is that whenever you have a base raised to some power and the entire thing raised to another power, you can actually multiply these two exponents up here. So this one here is going to become a to the sixth power. Alright, so now we have these two quantities to compare, a to the ninth power and a to the sixth power. Now notice, think of this as an imaginary empty box here between quantity A and quantity B, and you're basically going to determine whether you can write it as quantity A greater than quantity B, or quantity B greater than quantity A, obviously if they're equal to each other, or whether we don't know. At this moment, I don't know what's going to be inside that box. That's our job to determine right here. So even though I don't know exactly what's going to be inside of that box, I know that I can actually divide both expressions by a certain quantity. For example, if hypothetically, if we had an equal sign, for example, a to the ninth power equals a to the sixth power, I would be able to divide by a to the sixth power on both sides. You see that? And that will cancel this side here. It will become a 1. So I'm going to take the same approach, even though I don't know whether it's an equal sign, greater than, or less than sign that's going to be inside of the empty box. Alright. Now, there's another thing that we have to worry about. You see, for example, if I have two numbers, for example, like -1, an empty box, and -3. And we obviously know that -1 is greater than -3. I know that if I divide both sides by -1, because I'm dividing by a negative number, this inequality here would switch sides. It would go from -1 being greater than -3 to now switching up. Obviously, after you divide it, it's going to become a 1, and you're going to have on this side a 3, which is a true statement. 3 is greater than 1. So notice that when we divide by a negative number, the inequality must change sign. So that's something that I have to be aware of, because in that box, I don't know really what's going to be inside there. So if I have the greater than or the less than sign there, dividing by a negative number on both sides will switch the sign. But then again, and this has happened to me and to many other people, is that you forget about what's given, and it's given to us that a is greater than 0. So we know that both quantities on both sides will be greater than 0, because any number that is greater than 0 raised to some power, whatever power that might be, is going to be greater than 0. It's going to be positive. So I don't have that issue then here. I can divide without worrying whether the sign of the inequality must switch signs or not. Alright, so we have a to the 9th power, our empty box right here, and we have a to the 6th power. So I'm going to divide both sides by a to the 6th power on both sides, and this is to even simplify even further. You see, when I do this, dividing by a to the 6th power, this is going to become a 1 here on this side. Obviously, the empty box that I don't know. And here is going to be a to the 3rd power. Alright, so our job now is to determine whether a to the 3rd power is going to be greater than 1, less than or 1. Are they going to be equal to each other? Or don't we have any information at all to be able to determine that? They tell us that a is greater than 0. So I know obviously that if a is 1, I'm going to have here on this side 1 to the 3rd power, the box, and it's 1. And obviously 1 to the 3rd power is 1, and therefore I'm going to have that both sides are equal to each other. So we know that, for example, from the options, which you're going to have A, B, C, D, A for being quantity A is greater, B for quantity B being greater, C for them being equal to each other, and D, we don't have enough information. I would get, so far, I'm going to have quantity C as my option. That's not the final answer yet. That's one of the possible results that we've obtained here. Now, obviously, notice that if A is, for example, the number 2 to the 3rd power is going to be equal to 8, and obviously that is going to be greater than 1. And obviously, in that case, we would have A. Now, since they don't give us any further information, it could be that A could be 1, and we have 1 to the 3rd power. Or it could be that A is 2, and we have 2 to the 3rd power, which is 8. And in those two cases, we get totally different answers. And because we get totally different answers, we cannot really tell which one is it going to be. So, it's neither C nor A. Our answer is D. You have to give me more information in order for me to determine which of these possible options I should choose. So our final answer is D. We don't have enough information. That's it for the first question. I'll see you guys in the second question. I should post this recently, so it should be there. Take it easy. Bye.